Welcome to AI ConvoCast, where we bring you the latest in AI and tech innovation. Please don't forget to rate, review, and share if you like what you hear. Let's jump right in.
Today, we will be covering OpenAI's upgraded GPT Rosalind model for life sciences, ChatGPT's new Dreaming v3 memory system, Google's release of Gemma 4.12b for laptops, and a striking report that Apple's revamped Siri is leaning on Google Gemini running on NVIDIA hardware. Starting with OpenAI, the company rolled out a major update to GPT Rosalind, its purpose-built model for life sciences research. Announced on June 3rd, the update brings GPT 5.5's agentic coding and tool use abilities into a system designed specifically for drug discovery, genomics, and wet lab work. Think of it less as a chatbot and more as a lab workbench. Researchers at qualified organizations get access through OpenAI's Trusted Access program, and the system can now handle literature review, genomic analysis, protocol planning, and even interactive viewers for sequence, alignment, and structure files inside codecs. What stands out is the targeting. On Lab Workbench, which tests practical wet lab protocol assistance, GPT Rosalind scored 63.2% compared to GPT 5.5's 55.8%, and it did similar work on genomics benchmarks while using meaningfully fewer tokens. OpenAI described the release as offering greater intelligence grounded in real scientific workflows, and that framing captures the strategy. The race among frontier labs is no longer just about who has the smartest general model. It is increasingly about who owns the scientific operating system, where the stakes are higher, mistakes are costlier, and the productivity payoff for working scientists could be enormous. Next up, OpenAI also shipped a new memory architecture for ChatGPT called Dreaming v3, which began rolling out on June 4th to Plus and Pro users in the US, with free and Go users getting it over the coming weeks. The idea is that ChatGPT now synthesizes and updates what it knows about you in the background, so it can keep context fresh across long histories without you having to tell it to remember things. OpenAI says it solved a key scaling problem here, reducing the compute needed to serve Dreaming to free users by roughly 5 times, which is what makes the broader rollout possible. The pitch is simple. The model race has been dominated by reasoning, coding, and agents, but memory is what makes an assistant feel continuous from one week to the next. OpenAI says Dreaming v3 is meant to deliver the freshest, most relevant context across conversations spanning hundreds of millions of users and, in some cases, multi-year chat histories. There is also a new memory summary page where you can see what ChatGPT knows, edit it, add to it, or steer what should be remembered going forward. Early reaction on Reddit has been mixed. Some users welcomed the more personal continuity, but others complained that memory changes had disrupted carefully tuned setups they had built up over time. That tension between a smarter background memory and the loss of user control over older configurations is going to be the story to watch as the rollout expands. Moving to Google, DeepMind released Gemma 4.12b, an open-weight multimodal model built to run on laptops and workstations rather than in the cloud. It was announced June 3rd, handles text, images, audio, and video, supports a 256,000 token context window, and ships under the permissive Apache 2.0 license. Coverage the next day zeroed in on the local hardware angle, noting that a 12 billion parameter multimodal model is now practical on machines with around 16 gigabytes of RAM or VRAM, which puts it within reach of a lot of developer laptops. The technical twist is that Gemma 4 is encoder-free. Instead of bolting on separate vision and audio encoders, it routes raw image patches and audio waveforms straight into the model. For developers, that means simpler pipelines and one model that can handle multiple input types without extra plumbing. The bigger picture is that capable multimodal AI is moving off cloud-only APIs and onto local hardware, which changes the equation for prototyping, privacy-sensitive workflows, edge deployments, and cost. It also turns up the heat in the open model competition against Meta's Llama line, Alibaba's Qwen, Mistral, DeepSeek, and now NVIDIA, which has been pushing harder into open weights itself. And finally, a report worth flagging because of what it implies about the assistant wars. According to coverage on June 4th, Apple's revamped Siri is reportedly going to rely on Google Gemini, running on NVIDIA Blackwell hardware, to power its more advanced capabilities. If accurate, that is a striking arrangement. Apple, a company famous for vertical integration and for keeping its silicon and software stack tightly in-house, would be leaning on two of its biggest rivals for the brains and the compute behind its flagship consumer assistant. The takeaway is what it says about the difficulty of building full-stack assistant AI. Even Apple, with enormous resources, its own chips, and years of Siri investment, appears to have concluded that catching up to a frontier-quality assistant on its own timeline is harder than partnering. For Google, getting Gemini inside Siri would be a massive distribution win, putting its model in front of more than 1 billion iPhone users. For NVIDIA, it is more validation that Blackwell is the default platform for serving frontier models at consumer scale. And for Apple, it raises an uncomfortable question about how much of the assistant experience it really controls, and whether this is a stopgap while its own models catch up, or a longer-term dependency it is willing to live with.
Thank you for listening to AI Convo Cast. Please don't forget to rate, review, and share if you like what you hear. Thanks and hope to see you again next time.